Okay, Assalamualaikum and very good morning to all students. EPO 640 Electric Drive. So this is a recorded version of our tutorial session as requested during our previous lecture session. So this for today I will explain um, the the answers for tutorial 3. Okay, and so we start with our first question. That is the for tutorial DC drive part 3. Question 1. A 200 volt, 875 RPM, 150 amp separate excited DC motor has an armature resistance of 0.06 ohm that is fed from a single phase fully controlled rectifier with an AC source voltage of 220 volt 50 hertz. Okay, and we assume that it's on a continuous condition. So for this question, you have three questions, three sub questions. One is the Farad angle for the rated motor torque at 750 RPM. Number 2 is Farad angle for the rated motor torque at negative 500 RPM. Okay, and number 3 is the motor speed. Okay, if alpha is in 160 degrees at rated torque. Okay, so for this question, it's good if we can put in the schematic diagram, the circuit. Okay, so this is a separately excited, which is connected to the inverter. So we just draw the inverter. Okay, it's connected to the armature. RA is 0.06. You have your VA. Okay. So from here, the number 1, for question number 1, what will be the firing angle for rated motor torque at 750 RPM. Okay, so if you remember the three important equations, okay, so VA or EG equals to IRA minus VT minus IRA is also equivalent to constant times speed. So here we can find the value of the constant value. Okay, where VA is given 200 volt. Okay, VA is 200 volt. Okay, 200 volt. Okay, and then you have IARA 150, yeah. RA is 0.06, and speed 875. So we need to convert it into radian per second. Okay, so if we calculate this, you get okay, so EG at 750 RPM, okay, is, okay, you can put it in the equation, 2.085 times 750 times 2 pi over 60. Okay, so it's 163.74. Okay, so for the firing angle, okay, so for the firing angle, sorry, for the firing what's this? So for firing angle, PA is IA RA plus EG. So PA, to produce VA, they'll be using the AC to DC equation. So this is in the notes. Okay, full bridge. So for full bridge is pi. Okay, so cos alpha is IA RA plus EG divided by 2 set 2 Bs pi. Okay, so you can calculate this. 6 plus EG is 163.7 times pi divided by 2, so 2 times 220. Okay, and so this is cos theta. So theta is cos invert 0.8713, and you get around 29.4 degrees. So is it the same with the answer that we have in our question? 29.3. Okay. Okay. So that's for sub question number 1. So this one is for sub question number 1. Okay. So we have for question number 2. Okay, number 2 is the number 2 is rated motor torque at minus 500 rpm. So you have your armature equals to constant speed. Okay, so we already found the value of the constant at 2.085. Okay, so minus 500 times minus 500 rpm, and you need to translate this into radian per second. Okay, so you calculate this. Okay, so it's around 109, 109 volt. Sorry, in negative, okay. And the firing angle, okay, firing angle is KVA equals to BDC. Okay, again the same equation. So for full bridge, full bridge rectification. Okay, so we use this equation, IARA plus EG. So cos alpha is IARA plus EG times pi. So 2 over sec2 Vs, and we put in the values. 50 times 0.06 pi 2 sec2 over times 200. Okay, so it's around minus 0.546. Okay, and your alpha is cos minus 1 minus 0.546, sorry, 5046, 5046. So it's around 120.3 degrees. Okay, so note that this is alpha is the speed is negative, and the switching is within 90 degrees to 180 degrees. So if you remembered yesterday in our lecture, in our 4-quadrant drive, okay, so torque to speed 4-quadrant drive, so you can see that the speed value is negative. Okay, speed value negative, minus 500 rpm, means that it's in the regenerative braking region lah. So it confirms with the with what we have discussed yesterday, that if your firing angle is within the bound of 90 degrees to 180 degrees, so you have your speed will be on the negative region. Okay. So for number one, the speed drive is in the positive region. Okay, and on number two, it's in the regenerative braking region. Okay, so let's look at number three. Sorry, this will be number two. So just to mark here, number two. Okay, So number 3. Okay. So number 3 is so they already set the motor speed. So, okay, for alpha equals to 160 degrees, and at rated torque. So you have your VA equals to IARA plus your armature. So from another equation is your armature equals to 2 Vs over pi, okay, cos alpha minus IA RA. Okay, so we substitute VA with the output of the inverter. Okay, sorry, the output of the converter. So armature is 2 times 220 over pi cos 160 degrees, minus 150 times 0.06. So your armature is minus 195.24. Okay. Oh, why is it at the end? Okay. No matter. So this should be up, okay. Why is it? Okay. Trying to put it up, Oh, okay. 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 So, armature. Another the third equation, armature is constant speed. Okay. So we know it's we know the value, the speed value, EG we know, constant value we know. Okay. So just put in the value there. 5. So minus 93.6. So this is in red second, red second. So we put it in RPM. So we need to times 60 over 2 pi. Okay. And in RPM is around 894.5 RPM. Okay. So let's check. 8.94 here. Quite close lah. Okay. Okay, so that will be the answer for number 3. Okay. Okay, that's question number 1. Okay, let's label this as question number 1. Okay. Okay, so next will be our question. Okay, so question number 2. What was question number 2? So question number 2, a 230 volt, 1500 RPM, 50 amp separately excited DC motor has an armature resistance of 0.5 ohm, fed from a 3-phase fully controlled rectifier. Okay, available AC source has a line voltage of 440 volt, 50 Hz. Star delta connected transformer is used to feed the armature, so the motor terminal voltage equals rated voltage when the converter firing angle is 0. Okay, again we assume that is a continuous condition. Okay, so for this you have a 3-phase control rectifier with star delta connected transformer. Okay, so for the first question is calculate the transformer turn ratio, and next determine the value of the firing angle. Okay, so this is good if we can draw the equivalent circuit. Okay, so star delta. So let's draw the star delta connection. Okay, oh, why does it keep right? Okay, okay. Okay, so you have the star and then the delta. Okay, it's not a good figure, but at least can understand. Okay, connected to the rectifier, and then you have your output of the rectifier. Okay, and into your armature. So this will be RA, this will be the armature. The parameters. So this is a separately excited DC motor with 220 volt incoming, 1500 RPM and 50 amp. So this is on rated. It's rated. So okay. So the first question is, what was the question? Okay, calculate the transformer. Okay, sorry. Calculate the transformer turn ratio. Okay, turn ratio. Okay, so first we identify VO. VO is 3 V in over pi cos alpha. Okay, so VA is the V rated when alpha is 0. Okay, so transformer turn ratio, you can see one is without is within the V rated and the other one is on V out. Okay, VA. So VA is 220. Okay, equivalent to 3 over pi VE. Okay, VE is 220 times pi over 3 which is 168.8 volt. Okay, so you have this value is V line equivalent to V phase V2. So this will be the secondary. So for V phase primary, V1 is 440 volt. So 3 is 254 volt. So V1 over V2 is 254 over 160.8. So the ratio is 1.56. Okay. And question number 2 is on the firing angle A and B. Okay, determine the value of firing angle when A motor is running at 1200 RPM and at rated torque, and B when the motor is running at minus 800 RPM and twice the rated torque. Okay, so for number 2, okay, so I think we can so the firing angle A when omega is 1200 RPM at rated torque. So BA is IARA plus armature or IARA plus constant speed. Okay. So we need to find the value of K. So from IARA, K equals to 220 minus 50 times 0.5, 1500 times 2 pi over 60. So you get 1.242. Okay. So BA is 3 P in over pi cos alpha equivalent to IARA plus armature. Okay, so cos alpha is IA RA plus EG over 3 sec 2 E in, and we put in the values, 0.5 plus 1.24 times 1. Okay, put it in red, red. Okay, times pi. Okay, so this 2 times 162.8. Okay, so if you solve this, around 0.822, so alpha is invert cos 1822, so 34.6. So you can calculate this. So this will be A. Okay, and for B is when speed is minus 800 RPM. And torque is 2 times the torque rated. So we can say it's 2 times the current. Okay, so for test, and times and times 0.5 plus 1.242 times minus 800. Okay, and put it in red. Okay, divided by 3621628. So it's 0.2454. So alpha is invert cos 0.2454. We get 104.2 degrees. Okay. Okay, so for question 1 and question 2. Okay, so we will continue with question 3 and 4. Okay, we will continue with 3 and 4 in part 2. In part 2. Okay, so I'll see you again in part 2. Thank you.